Alright, so the final section of our review today is on writing inequalities. So once again, these are your inequality symbols, greater than and less than. We've also included equal to here. So let's get started. There's a competition to guess how many gumballs are in a jar. So Mikhail thinks there are less than 100 gumballs in the jar. Write an inequality that represents Mikhail's estimate using the variable g to represent the number of gumballs. Okay? So we're using g, and the number he talked about is 100. And he said that there are less than 100 gumballs. So his amount, so once again, g is number of gumballs. And he's saying that the number of gumballs has to be less than 100. So that would be his inequality. Mikhail is saying that the number of gumballs is less than 100. Now, Soraya says there has to be more than 50 gumballs in the jar. So write an inequality that represents Soraya's estimate. Once again, we are using g to represent the number of gumballs. So Soraya thinks the number of gumballs, she used the number 50, is greater than 50. Okay? So Soraya says that the gumballs, she doesn't know how many there are, but she knows that there's at least 50. There's more than 50. Would they both agree that there are possibly 63 gumballs in the jar? Write an explanation why or why not for both people. So let's think about Mikhail. Mikhail said that there's less than 100 gumballs. Is 63 less than 100? Yeah. So if we took Mikhail's inequality, 63 is less than 100. Well, that's true. So once again, we're substituting. That's when you replace a variable with a value. So, and if it's true, then it works. So, Mikhail would agree because 63 is less than 100. And that's all he said. He said, I don't know how many there are, but I know there's less than 100. So for Mikhail, 63 would be a valid estimate. So now let's substitute again for Soraya. So Soraya once again said that the amount of gumballs has got to be greater than 50. So let's substitute in 63. And I get the inequality 63 is greater than 50. That is also true. So Soraya would agree with that as well. Because 63 is greater than 50. So the number 63 satisfies both of their inequalities. Both of their estimates work for 63. So now, why would Mikhail say 45 gumballs is a possibility, but Soraya would not? Write an explanation for each person's inequality. So once again, I'm working here with the number 45. So I'm going to substitute that into Mikhail's. Once again, Mikhail said G, the number of gumballs, is less than 100. Well, 45 is less than 100. So Mikhail agrees for that reason. 45 is less than 100, which is all he said. Nothing more specific than that. Now let's do the same thing for Soraya. So Soraya said that the amount of gumballs has to be greater than 50. And that is false. That is not true. 45 is not greater than 50. So Soraya would disagree, because she said that there had to be at least 50, more than 50, and 45 is less than that. So once again, when we're working with inequalities, you always need to have a variable to represent the possible values. And then when you're given a certain number to see if it satisfies the inequality or makes it true, that's when we do that old substitution, replacing the variable with a value or number. And now for the final page. Looks a little bit like this. So you have a series of number lines, and you need to write inequalities for them. So when we are writing inequalities, we can always represent them on a number line, right? So what we need to do, where you see these blue arrows, those represent all of the possible values of x. That's why there's a blue x beneath each of them. So for our example, it's saying x is less than or equal to -40. So you can see that the line that represents x starts at -40, and then it goes to the left. And as we go to the left, it goes less, right? Left is less. So x can be -40 or any number smaller than it, because that arrow indicates that the possible values will just go on for infinity. It'll never stop. That's what an arrow on a number line represents. Another important thing to note is that when you have a closed circle, that means greater than or equal to or less than or equal to. So in this situation, it is saying x could be -40 because -40 is filled in. So that would be a possible answer for x. And when we have an open circle, that's just greater than or less than. Okay? So the difference here is, let's say I had x is less than 5, or x is less than or equal to 5. Here, so previously we did a problem where we said that the cost of books must be less than $5. So in this situation, the price of a book could not be 5. It must be less. So if we were talking about the cost of books, then it would start at $4.99, would be the biggest it could be. Here, if we said the cost of books could be 5 or less, it could be 5. It's including 5. So 5 would be a good answer here. So there is a difference between less than and less than or equal to. I know you don't know how to type that in on a on your computer. So if you ever have one filled out like this, like the example was, you can always write x is less than 40 and x is equal to 40. That would just be a way of showing both of those without having to figure out how to type that in on your calculator. Okay, so now for number 1, it's saying, once again, the blue arrow represents x. So in every single situation, we're talking about the possible values of x. So we're going to have x on every single one of these. Whenever we write inequalities, now to represent a situation, you need to have a variable. If you're talking about the price or the possible temperatures, whatever, you need to have a variable, which represents an unknown quantity. It's saying x, it starts at -1, and it goes to the left. And left is less. The numbers are counting down. They're getting smaller. So x is less than or equal to -1. So it could be -1 or anything less than it. And once again, if you can't type that in on your computer, you can say x is less than 1 and x is equal to -1. Now here, all right, it looks like x is starting at -75 and it's going to the right. And I've got -70, -65, 60. So as we go to the right, we're getting closer to the positive. The numbers are getting larger. So this one would be x is greater than negative 75. And notice I'm not putting that line beneath, because once again, when it's an open circle, that means it does not have the or equal to. So x could not be negative 75 here. It could be negative 74.9999, right? So when you don't have that or equal to, it can be right up next to that number that you're talking about, but it cannot be that number. Okay, so that's what that open circle means. All right, now number 3, looks like we are starting at 130, 135, 140, so we're getting bigger. So x is greater than 130. Here, x is starting at 20 and going to the right. We can see numbers are counting up, so x must be greater than 20. Here, for number 5, looks like it's starting at 20 again, but this time it could be greater than 20, or it could also be equal to 20. All right, because we have that closed circle. Here we've got negative 190, so x starts there, and it goes to the right. So the numbers are getting closer to the positives, they're getting larger, so x could be 190 or anything greater than it. X is greater than or equal to negative 190. 7, looks like x is starting at 80, and it's going to the left. Left is less, we're counting down, 70, 60, 50, 40, 30, 20. So x is less than or equal to 80. X is greater than negative 130, starts there and gets larger. Number 9, x is going to the right, getting closer to the positives, must be greater than or equal to negative 140. X is greater than or equal to 70. X is greater than 90. Could not be 90. It could be 90 and 1/10 or 90 and 1/100th or whatever. Very, very close to 90, but it could not actually be 90, so x just must be greater than 90. And x here is less than or equal to 200. It starts at 200 and then starts counting down. And x is less than or equal to negative 7. So once again, negative 7 could be a value or any number smaller than it. And once again, whenever you see those arrows in math on a coordinate plane or on a number line, that is supposed to indicate to you that that goes on for infinity. So x could be less than or equal to negative 7. So in theory, x could be negative 100 million, right? Like the possible values just keep on going forever and ever.